Hello students, good evening. So I hope you completed the exercise 1.1 and examples before the exercise. Today we are going to start the another topic, that is types of sets. Okay, so first one will go is an empty set. So what is the definition of empty set? A set which does not contain any element is called the empty set. That means there will be no element in that set. We can call it as an empty set or null set or void set. Okay, so you can use any name, maybe different books use different names. Now, the examples of an empty, how it is possible a set has no element. Let's take an example. I taken A as a set, natural number between 1 and 2. Can you find out any natural number between 1 and 2? There is no natural number, right? Because between 1 and 2 I have infinite number of rational or irrational numbers, but we don't have any natural number between 1 and 2. So empty set, we will write it as this one, where inside it there will be no element. Okay, now if I go for the another example, B set, a student studying in class 11 and 12. So is it possible for any student to study in class 11 as well as class 12 at a time? It's not possible. So there are no elements in set B, that's why we call it as an empty set. I hope you understand the definition of an empty set. A set which does not contain any element, that we call it as a empty set. So now what you have to do, think of your own and give two examples in your notebook when you copy it. Write two more examples. I have given A and B, so you write C and D, two sets which are examples of an empty set. So when I discuss about the empty set, if somebody writes this way and the curly bracket 0, so I cannot say it is a empty set, because this is a set consists of an element 0. Okay, so this is not an empty set. Don't think that 0 is there, so it has to be empty set. Empty set symbol is like this. There is nothing in the bracket. Okay, so next one will go as finite and infinite set. So finite and infinite sets will talk about based on the number of elements in a set. How do you find number of elements? Let me give the definition first. A set which is empty or consists of a definite number of elements is called a finite. If it is not a finite set, then it has to be a infinite set. Okay. So take an example of a finite set. If I take A as 1, 2, 3, 4, 5, 6, and 7. So there are only 7 numbers. I can count them. Okay. So that's why we call it as a finite set, because there are finite number of elements in a given set. If I take set B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So I have taken all the natural numbers in set B. So do you think natural numbers are finite? No, they are infinite. That's why we call it as a infinite set. In a set, if there are finite numbers, that is a finite set. In a set, there are infinite numbers, then it is a infinite set. So this definition of finite or infinite totally based on the number of elements in a set. So when I say number of elements, I'll write number of elements of A here as 7. So this is the notation I use for representing number of elements of a set A. How many elements are there? 7. And if I want write for this number of elements of B equals to infinite. Maybe you can use that infinite symbol also, no problem. Okay, so you understand what is finite set and what is infinite set. Now if I go to the third example, equal set. That means if I have two sets A and B, can I say whether they are equal? If they are equal, what are the conditions to be satisfied? So first see the definition. Two sets A and B are said to be equal if they have exactly a same element, not same number of elements, they must have same element, and we write it as A equals to B. Otherwise, the sets are said to be unequal, and we write it as A is not equals to B. Okay, so this is the symbol of not equals to. It means A and B sets are not equal. Let me take the an example of set A and B. I have taken A as 2, 3, 5, 7, 11 and B as 3, 5, 11, 7, 13. If you see number of elements of A, there are 5 elements in A, and number of elements in B is also 5. So, but still I cannot say A equals to B, because if you see here, 2 is an element of A, but there is no 2 here in none of the element is 2, and 13 is here, and there is no 13 here. Okay, so A has the different element and B has the different element, so hence A is not equals to B. Okay, so I can say here A is not equals to B. If I go to the another set C, X such that X is a prime number less than 13. If I convert into the roster form, what are the prime numbers less than 13? 2 is a prime number, 3 is a prime number, 5, 7 and 11. These are the prime numbers which are less than 13. I have not said that less than or equals to 13. So we use the word only less than, so I cannot include 13 here. So 2, 3, 5, 7, 11. Now see the elements of C and the elements of A. What do you say? Are they equal? Yes. Number of elements are same, and even each and every element of A is also an element of C. So hence here I can say A equals to C. Actually, you have to use the capital letter to represent the set. So let me put here A equals to C. As I said, A is not equals to B and A equals to C. So what do you say about C and B? Whether C and B are equal or not equal? Obviously they are not equal, because A is not equals to B. So, and A is equals to C. Obviously C has to be not equals to B. If you don't know the rules, then you can compare the elements of C and the elements of B. If you think they are same, then they are equal, otherwise they are not equal. So these are the types of sets which you have: empty set, finite or infinite set, and equal set. So you can start go through the definitions, and examples are given in the textbook. Solve the example first, then you start the exercise 1.2. So if you take the examples here, state which of the following sets are finite or infinite. X belongs to n, x minus 1 into x minus 2 equals to 0. If I solve these equations, I'll get x value as 1 and 2. So there are only two values which satisfy this equation, so it is a finite. Then I have x square equals to 4, where x is a natural number. So there are only two values which satisfy x square equals to 4. One is x is minus 2 and x is plus 2. So hence, this is a natural number, so even I cannot take minus 2. I have to take only plus 2. 2 square is 4, hence it is a finite set. 2x minus 1 equals to 0. So if I solve this equation, I'll get x value as 1 by 2. But x has to be a natural number. 1 by 2 is not a natural number, so this is an example of a empty set. So even empty set is also a finite set. Next one is x belongs to n. X is a prime number. So in natural number, how many prime numbers are there? There are infinite prime numbers. So it is a infinite set. X such that x is a odd and x is a natural number. X is odd and x is a natural number. How many natural numbers are odd? There are infinite. So first you have to extract the element, then you have to decide finite or infinite. So like that, if you go to exercises, there are a lot of there which you have to decide whether finite or not. For example, x is a natural number, x is less than 5 and x is greater than 7. Less than 5, 1, 2, 3, 4, greater than 7, there are infinite. Okay, so this is not an example of an empty set. This is not an empty set, right? So like this. Thank you. Continue with the exercise questions. Have a nice day.